Hello and welcome to Chaos and Caffeine. If you're watching this on YouTube, make sure to like and subscribe. In any case, today we're going to have a little fun. We are going to try a new coffee, and then we're going to compare it to two of the earlier coffees that I tested. Two of my favorites, as a matter of fact. I'm sorry, let me correct that. Two of my favorites from the standpoint of Keurig-based coffees. The shop floor coffee really made my day. But in any case, we're going to, this time, try out a coffee I picked up in Walgreens, of all places, in which the coffee came out to cost per Keurig cup about 25 cents. Now, this is as opposed to the Death Wish coffee, and I'm going to use the brand. I'm not using the Valhalla for this, and you'll also note I have in stock now, in our stock, for the kitchen, for the employees, the Nice from Walgreens. This is a brand they carry, the dark roast. Here I have a medium roast as well. So we're going to go dark roast versus Tactisquatch, which is also a dark roast. The beans are all from different areas and so on, but I want to do just a personal comparison to see if a 25-cent coffee can go up against those that cost more than $1 a K-cup, meaning that cost me 25 cents a K-cup, and this cost me right around $1, right around $1.25. So, we're going to start out with the Nice coffee. And I like the name. It's nice. So I did what we did before with our comparisons, and I put them each in a styrofoam style cup. I'm going to do something fun though, because there's a lot of coffee here, and we may talk for a little bit. In any case, once we finish this, we are going to discuss definitions of electrical and current signature analysis and how they've kind of evolved over time. So that should be quite interesting for those of you who are in my end of the business. So let's start out, because I haven't had my coffee yet. I'm going to start out with Nice. Now, I have tried all of these coffees before, so I'm a little biased, but let me go ahead. Now, it's a French roast. So it has a little bit of that bite at the top of the tongue. And now what I did is I took the smallest setting on the Keurig for about, I think, a 4-ounce cup. So these are stronger than normal. Very good. So that is the first one. I didn't bother looking to see where the beans are from, so I'm going to put this in my Motor Dock cup. Now what's going to be fun is we're going to mix them all and try them all at the same time and see how that all fits. I wouldn't need to use a pinch of salt in there. It's not bitter. It is as strong as a dark coffee, and that is this. And I got it from a Walgreens, of all places. So I'll put that there for a little later. Let's go ahead and try it against Death Wish. Now, Death Wish is the first branded coffee of this type that I kind of got involved in a long time ago. If you want to see the story, go take a look at it. But they had sponsored me for a while as a lifter. So let's go ahead and give this a try. This is the Death Wish coffee. Okay, just like I talked about before, just a little bit of bite. And there's an after flavor, which is quite nice, kind of like a chocolatey cocoa type flavor. How does it compare? I would know the difference if I picked them up, but I would take either. So first test is really not a significant issue. So that is now in the cup. Whoops. Got to be careful, put it in the right cup. And finally, we're going with Tactisquatch. And everybody knows that I'm into Reliasquatch, but this is Tactisquatch, which is a registered trademark. So in any case, we're going to go ahead and give this a try. This is from Black Rifle Coffee, which is a veteran-owned coffee, just like the other organization I tried, the ARC Coffee or Aerial Resupply Coffee. Again, another outstanding one. I think I've only had one bad coffee, and I won't even mention it. Let's go ahead and give this a shot. You know, one thing I do have to say, and I haven't tried these side by side before, is a Tactisquatch. I wonder I buy it in large cases. Is a lot smoother than the other two for a dark roast. I mean, I could sit there and sip this all day. So if I were to say which is the winner between the three, I actually thought I was going to say Death Wish, but Tactisquatch definitely beats it all to the punch. I'm going to be ordering another case of that for the team. So there we go. That's the way it is. Let's go ahead now, and we've mixed them all together so that this will last me for a little bit. This is a 14-ounce cup, and it is definitely, this is our Motor Dock cups. I have some still in stock. What we might do is a giveaway in a future one. So in any case, you know what? Let's do it. So by the end of the thing, at the end of the presentation, I will have a contest. And what we're going to do is for the next one, we are going to give away a Motor Dock cup, insulated mug. I love them. I actually ordered them as giveaways at one point, but I like them because I can, in my 14-hour drives, I'll sit there and I'll have it, and it'll keep that coffee warm literally all day, even in the winter. So I'm sure it does okay for cool drinks, but I'm not an iced coffee person. And there goes the thunder and lightning that went along with that. So in any case, let's go ahead and see what happens when we mix them all. Ew. No, just kidding. Quite good still, so I am not going to have a problem drinking that. 3 great coffees. So if you're stuck on a budget, I mean, I literally went in there and my jaw dropped when I saw this stuff. So somewhere, I think I went back there and I got the medium roast, and that came out to be somewhere between 25 and 50 cents. But if you've got a Keurig and you don't want to spend a lot of money, I would definitely go with this. If you're into the rest, these guys here and ARC Coffee were great. Shop Floor Coffee was outstanding. I think you can only get that as a ground or bean. But that's neither here nor there. And if you haven't had a chance, follow all these guys. I mean, especially Death Wish Coffee. I'm sorry, Death Wish Coffee has some fun stuff, but the real one's ARC on LinkedIn, and then Black Rifle you'll find on YouTube. Matt Best's videos are fantastic. Okay, let's get into the fun part. We've gone far longer than I expected on that. Hold on a second. Here we go. We are going to talk about electrical and current signature analysis and kind of where things have gone. There are standards in this area, and I'll be quite clear. I am in the process. I chair one of the standards that's being reaffirmed. It's going to be a major rewrite, but that's neither here nor there, especially even with the definition. I just read through it the other day, and I went, I remember all that argument. There are a number of standards. There's one specifically called ISO 20958, which is electrical signature analysis of three-phase induction motors. This one is very specifically, it's a 2013 edition. This one is very specifically aimed at electrical signature analysis. And there's a bit of history in this. In 2006, a group, because they wanted, ISO wanted to work on a standard for electrical and current signature analysis, a group got together. We called ourselves the Institutes of Electrical Motor Diagnostics. I still own that website, although we've shut down the website itself. We had kicked off a not-for-profit. It was based out of Illinois, and I was the executive director. And we were having input through the tag on the development of the standard. So we had a team of over 200 with emphasis on organizations like Cargill and General Motors and Allied Services and a bunch of others, as well as we had all of the major at the time, commercial electrical and current signature analysis companies. So we had Altest, Framatome, Arriva at the time, the Empath basically. So both of those were basically the Empath system. The Baker Instruments, that was the Explorer. Ernesto Weidenbrug was involved with that. And then we also had PDMA. And all of these organizations were heavily involved. So we really made it a thing, and we were in the process of writing the document. And 2008 happened. And then on top of that, the chairmanship of the standard changed to an academic, I believe it was out of South Africa, and he scrapped everything and said the only way to do it was through the Parks vector approach, which to this date, I only am aware of it ever working in a lab, as in identifying that a fault exists. So that's kind of my take on it, because if it worked, I'd be using it. We design our own thing. I just have not had any luck with it. It does require 3 phases of current, though, so for that one. But anyways, let's go ahead and talk about how they defined it. So what kind of happened here when IEMD went ahead and folded, because all the companies pulled out? We were charging $1,000 a year to keep the organization running. When we closed, we kept good books, and we basically used the final funds to clean up all the stuff that was going on. We covered the travel for a representative going to the Europe for the ISO meetings and so on. In any case, let's talk about it. So they call it electrical signature analysis of 3-phase induction motors. Now this became the document that came out there and causes a lot of confusion, because they do talk about stator current analysis, electrical current voltage and power analysis, which that's kind of the one that was defined before as electrical and current signature analysis. Magnetic flux analysis, partial discharge analysis, electromagnetic interference testing, rotor current analysis, shaft voltage analysis, and then an annex informative called Park Vector's approach. It was informative because nobody had applied it, and we're hearing about some places attempting to do that now, which would be interesting to see how it works in the field. Again, I've had no luck with it. That doesn't mean it's not possible. I always remind people of that, because it happens to me all the time. Well, I haven't figured out how to do it, therefore it can't be done. I had that literally thrown at me by some academic at the Power Engineering Society, trying to explain to me that a wind turbine had 2 inverters in it, which isn't true, but he needed that for his model to work. So therefore, that must be accurate. That's all. I think I've talked about this already. I am not thrilled with the way academia has run to just software models only. And that lightning strike hit something. But neither here nor there. We are fine. If the lights go out, we'll be on battery. In any case, there it is. If you heard it, yeah, we're going through. It was supposed to be a nice sunny day, and today's the picnic day for our homeowners association, which I wasn't attending anyways. Go get them. So in any case, this one kind of went in and did a hodgepodge of everything. You'll notice it doesn't say power quality. Now, so this is the defining guide. Now, what we've run into is a lot of companies that are using power quality devices. Now, by definition, power quality becomes part of electrical signature analysis because you need that kind of card or you need that kind of information. So by default, every electrical voltage and current signature analyzer, and for what we do with one of our, the Empower, is we'll do a phase of current. So we do some power quality stuff there in terms of harmonics. But let's get in here, and yeah. So this idea of power quality only does not exist in these standards. Now, we've seen some power quality standards that refer to electrical signature analysis, and that is an IEC standard. I'm sorry. We will cover that. I think that's an electromagnetic standard, 61000.4.30. And I'll mention that shortly. So, purpose of condition monitoring: if a motor is supplied from variable voltage, frequency, care must be taken. Stator current analysis refers to measurements of the stator current. However, the stator current is also affected by air gap fluxes in the rotor current. Stator current analysis is capable of detecting problems in the rotor and driven equipment. Okay, so that I will say the people involved did not understand the technology. We had no true ESA people involved in the standard. We were kind of left out and not invited back in because we wanted to talk in terms of spectral analysis. And in this case, because Iris Power Engineering at the time was involved, there was a very specific focus on it being rotor bars. And then reference-driven equipment stuff, because all of us knew from the Howard Haynes work of the 1980s and NAVC, as well as later studies, in particular done by MotorDoc, and all of the academic studies going on, is you can absolutely see well beyond the rotor. In reality, electrical signature analysis, and not my opinion, but not mentioned in these standards, is the measurement of the magnetic field air gap, or the air gap magnetic field of the machine through stator current. So the sensor is actually the magnetic field, not the stator, not the rotor. This is important in understanding and able to decipher certain equipment. But when you have people that are marketing types, maybe some engineers doing things, you get kind of funky results. Now, there's nothing wrong with the standard. It's good. It references things. But all the references are kind of self-serving. They don't really reference in the bibliography. They don't really reference anything outside of basically the people who sat in the thing. So lots of stuff on Park's vector approach by the people that were involved. The stuff having to do with the current signature and everything else by the people involved. So really nothing there. And I'm beating this up because I was very disappointed, but we had a standard that was specifically for that. We're in the process of changing that through a number of things. I've invited, and just so you're aware, when I talk about the CGRAE project that we're involved in, which is, I'm the chair, CGRAE A1.78, Guide for the Application of Electrical and Current Signature Analysis of Electric Motors, Generators, and Powertrain. So that basically means it's a guide for looking at what ESA and MCSA can do for an entire system, making sure that all of the players are invited on board, especially those that disagree with me. I believe in strong debate. Any standard, any document of this type should be should be consensus, meaning that we all agree. Otherwise, if I just wrote it and I say, oh, look, I have a standard, well, that's marketing. And if you follow me, and if you have followed me forever, you know that's not my thing. So I'll get another one out of the way real quick. The American Clean Power Gearbox Playbook, based upon our work, we have included, and there was another organization involved at the time. They kind of disappeared from the ranks, but that was the American Clean Power Gearbox Playbook, and there's a section in there describing that electrical signature analysis can detect issues in the gearbox. We know that from having done it since 2003. So over 20 years of a high degree of accuracy, meaning over 90% of the detection of problems in gearboxes, etc. Okay, so let's get into a standard that I now, because I'm talking about the standards I'm involved in, as of this past week, it's now official. I am the chair of, let me make sure I get that page there, of IEEE 1415, which is the IEEE Guide for Induction Machinery Maintenance, Testing, and Failure Analysis. The 2006 version has been withdrawn, but it's been administratively withdrawn, meaning that at the time there was really nobody took it on. Well, technically I did. I was made the chair in 2018 briefly, or 2017 to allow it to retire in 2018. I was supposed to take up the chairmanship again at that time. It was handed to an academic out of China who sat on it from 2018 until this year. Now, what had happened through all this time in about 2000, the IEEE Power Engineering Societies, there's an electric machinery committee, and under that, the motors subcommittee was responsible for this standard. I've been involved in the materials subcommittee, which is where most of the other testing is. We'll talk about that another time. Since 1993. Anyways, I got the 31st anniversary email during the meeting this year. Anyway, so 1415, I was originally the secretary. It was a hodgepodge of all kinds of stuff. Everybody wanted to get their technology into it. I think what I'll do is next week I'm going to have a little fun, and the chaos and caffeine will be what happens in standards meetings. So so we had a solid group of people that sat in the meeting, but a lot of them had their focus. So this is supposed to be how to do a root cause analysis, how to select maintenance testing for form wound motors at the time. We are in the PAR that I submitted, which has just been approved this week. It'll be reapproved again in January because we would only have 2 years to sorry, some wind must have blown something. It sounded like somebody was in the building, but it's a day off for everybody. So in any case, 2 years of left to come up with everything, and I didn't want to have that deadline. Otherwise, the PAR would run out, and we'd have to start all the way from scratch. So instead of launching it right now, and I need to assemble the group in any case, we're allowing the PAR to run out, which will be December 31st of this year, and then the new PAR starts on in the first couple of weeks of January. Doesn't mean we won't be working on it. It's a reaffirmation. That means, folks, that while this is called administratively withdrawn, as soon as that was voted, this is now still a valid standard. So a lot of people going, oh, it's withdrawn because they have commercial reasons for it. So in any case, there's a long history behind this one. I mean, yeah. So 2006, this one was official. It caused all kinds of consternation commercially, which is not supposed to happen in standards, but it does. So this one includes all of the different methods for testing these. We are now including generators. So wind turbine generators will now fall under this because they're not synchronous machines. So asynchronous generators will fall into this. We are going to be including an actual root cause analysis methodology, something that this standard was supposed to have in it that came down to a single chart. EPRI and other organizations have assembled those charts, so we will be borrowing heavily from all kinds of people's work. And that's the whole idea behind a consensus standard. In any case, this one here, let me get up to the right page. I'm looking at it as a reference, by the way, sorry. Covers current demodulation, running current testing, current signature analysis, starting an inrush current, torsion analysis, voltage balance, distortion and drop, voltage level, and voltage spikes. A lot of things are not in here that should be. So the standard is quite extensive for that time. And one of the things that we will be looking at, okay, so current demodulation, current running, current signature analysis, inrush or starting current. We're going to look at all of this stuff, and these should have been definitions and not testing methodologies. The reason it got broken out that way is the objection of some of the commercial entities, which of course they didn't survive. Surprise, surprise. Everybody threw their stuff in there. There's a whole bunch of stuff not in there. There's a whole bunch of new standards we're going to be incorporating into this. But basically, in this case, current signature analysis is the analysis of stator current using frequency spectrum analysis techniques measured in dB that can yield sideband harmonic information, and then it emphasizes rotor bars. It may require constant load conditions, and that was a problem because some of the technologies, and these technologies are still out there, that existed at the time could only do across-the-line constant load testing, one in particular. And there were reasons for that, and that made it a powerful tool for across-the-line machines. Not so great when it came to most modern applications, let alone when harmonics were present. Those machines became quite popular in the utilities. So there we go. That is going to be one. Now it will cover all of the technologies that are covered within standards. So the fact that ESA is now covered under an ISO standard as well as several others is important so that we have something to reference when we put this together. Books and everything else. So we've got my book. We've got the book that was written by Ian Culbert and Bill Thompson. So we have lots of stuff to cover electrical signature analysis. Now, what's interesting is when we get into a couple of standards, including the ISO standard, people are going to think that, because of some of the things I talk about, and in particular when I mention the Park Vectors thing, some people will think that I am anti anomaly detection. Well, if I was, I wouldn't have developed those technologies myself as well. I just think they're being presented wrongly. And then some organizations are trying to pass off power quality testing as ESA. Now, they're getting away with it because it is kind of squishy in the standards because people made them too vague. It's absolutely important, just like vibration analysis, that we get down to brass tacks. Because there's people who took advantage of the vibration end as well, and what they did is they took overall vibration technology, got that out there, and that somehow became the thing. They were claiming it was the same as vibration analysis. So vibration testing and overall vibration is very different from vibration analysis, which requires a spectral analysis of the system. We're going to be defining those through the upcoming standards. Now, where else are these mentioned? Well, IEEE 1068, which is the IEEE standard for the repair and rewinding of AC electric motors in the petroleum, chemical, and process industries. And just so you're aware, the reason they put that last bit, petroleum, chemical, and process industries, is because of the organizations that's behind it, which is the Petroleum and Chemical Industry Committee. So they are focused in that area and not everybody else. This is basically similar to the ANSI ESA AR100. It mentions electrical and current signature analysis quite frequently, both data from in the field, and then the one thing that I had a serious problem with, and in addition to, well, it was kind of a pot shot, but in any case, IEEE 1068, in there it says, well, you can't really use ESA or current signature in a repair shop because you need at least 50% of load. The problem there is the person involved in that also wrote an article and cited things in the ESA currents which was completely wrong. I mean, ridiculously so. And that's not just objecting to it. It's like pointing at things that had nothing to do with what the issue was and saying it was something completely different. I'm sorry, not mathematically possible. And downplayed the technology tremendously because they sell vibration equipment. So neither here nor there. I don't like it when commercial entities try to damage other competing technologies. I believe ESA and current signature is a disruptive technology, and we see a lot of these, especially the new sensor companies that are investor-owned, really attacking any technology that comes in and threatens their ability to make money. So that's neither here nor there. How was it put in the Reliable Plant by one of the other speakers? It was basically, I loved his analogy. If you see a company going through round whatever, you're not the customer. And the implication was the investor is the customer. So IEEE 1068 mentions it quite a bit. Doesn't give any real data in there, but then again, we'll give it for example. Some of the reference parts in the latest version of 1068. Yeah. So I was in the original one when we made the major change over to it being more than a 25 pager. It's now a 90 page thing. They didn't even send it out for me to vote on. I heard what happened from a, basically from there's a lot of stuff that happens in standards we'll talk about the next time. But let's just say there were people who did not want me in the standard for things like core loss and so on, because I would have held things up. So let's get into some of the other stuff. IEC 61000.4.30, which is a 2023 edition, is a testing and measurement technologies, power quality measurement methods. Now, here is where things kind of got squishy, in particular recently, because a couple of companies wanted their stuff to be called electrical signature analysis. So they do a lot of discussion in this on conditions for power quality, but also have some reference to certain things having to do with current distortion and interharmonics, which is an application related to ESA testing. So part of the problem with that is that's not what it was meant for. And there's no definition in here at all related to it. So interharmonic component is spectral component with a frequency between two consecutive harmonic frequencies, which is what they're using to try to define power quality testers as ESA devices. The ISO 2958 doesn't help very much because it kind of does a reference as well. Now, there is one called from 2009 called IEC 6003424, which is the online detection and diagnosis of potential failures at the active parts of rotating machines and of bearing currents application guide, which it talks about kinds of electrical signature analysis. So it gets into things like search coils, air gap flux, things like that. And this is what started the arena of these flux sensor devices. And we'll talk about that. I created one at one point that I referred to as a flux sensor powered by pixie dust. I called it the flux capacitor powered by pixie dust. The challenge I have with that is, yes, we will actually see some of the same signatures that look just like current signature analysis in a laboratory environment where I'm shielded from things like LED lighting and other EMI components. Now, part of what they try to get around is taking the data directly from the shaft output, because the people that are involved in that stuff begin to forget if you're taking this stuff outside the machine, very, very low values, it's a Faraday cage, and you're measuring leakage current, and you're measuring all of the surrounding stuff. And we did one demonstration once at a repair shop, and as we were testing, the crane went overhead, and it had LED lights on it that were failing, so they were blinking, and we could see every blink from those LED lights, which were dozens of feet away, as we were testing a 200 horsepower motor, which we could not see anything from the winding in that because of the way we had it set up on the test bench, and it was a good motor. So what we did pick up was a lot of the flickering light that went overhead, which was sending all kinds of alarms and alerts off in the software. So let's take a look at this. Page 10 of this is supposed to give the definition. It's after the tables. Okay, a valuable detection method shall be able to detect failures at an early stage. Therefore, this is electrical signature. Therefore, signals disclosing a rapid change in case of small deficiencies are optimal for the intended purpose. By contrast, signals which vary only insignificantly should not be used as the basis of the diagnosis. And in this case, they're thinking in terms of linear. Stator current voltage analysis, the analysis of terminal voltage or currents of rotating machines, and then it goes into this definition of just the overall values. It does talk about some of the challenges, and let's get down to okay. I've got an incomplete copy. Okay, so in any case, it does talk a little bit about the system. The signal processing needs the availability of appropriate electronic equipment, although the resolution of modern devices is high. Signals which do not exceed excessive precision should be preferred in this respect. Now, this is the 2009 edition. What you just heard was basically a discussion around the limitations from some of those who sat on the committee. They normally, for IEC, they do not keep a list of acknowledgments of who sat in the committee, but we do talk about inter-turn faults, phase-to-phase short circuits, double earth faults, static and dynamic eccentricity, cage imperfections, and varying currents. So this is primarily the discussion of things like vibration and electrical and current signature analysis. Does include partial discharge and then earth fault detection and core imperfections, as well as vibration. So that is a quick overview of the standards I am aware of related to electrical and current signature analysis. There's a lot of documents, a lot of work built around it. It has been the stealth technology, I like to call it. It's a technology that has definitely been in the background as vibration really is pushed forward, and the amount of money going into some of these companies, when we have them talking about receiving funds for a test equipment company of anywhere from 28 million in a single investment from a government to hundreds of millions, because everybody thinks that there's this $55 billion plot of money because everybody's jumping on board, especially corporate boards, to perform predictive maintenance of their technologies, something that has been wishful thinking in the industry for forever. For well over a century. Most companies, when you hit the board of directors, don't, cost avoidance and stuff like that just isn't on the P&L. However, and this is why I push the whole energy perspective, things like energy losses or corporate missions for zero emissions do have an impact, and those are the KPI that I like to use, which have been quite successful. But that's neither here nor there. Main thing is electrical and current signature analysis. I did promise just a quick overview. We do see such things as spectral analysis. That is, I like to call it true electrical and current signature analysis of the measured voltages and currents at the motor. Motor current and current signature analysis are current-related data, can be taken with a single or up to 3 phases of data. There's some other variations. We have not released those yet, and nobody else is doing those. We will talk about that when we release it. And then there are a few other really, really, really cool things out there along those lines. Anomaly detection is kind of like your overall reading, like overall vibration reading. I've done presentations on that recently showing the dancing effect of the spectra, which makes it a little bit challenging. We have in particular overcome some of that. Some other companies do an okay job, but tend to fall under more false positives than negatives. Or, well, you don't want negatives, more false positives than true positives. You have to watch for that, and we go from there. So in any case, really appreciate your time. I went beyond the time that I usually talk. Actually, it seems like this is going to be like one of those 30-minute to an hour type thing. We are working on some possible guests down the road, in which it'll be a little challenging because we have to have them drinking the same coffee. But neither here nor there. That's actually not half bad. So with that, thank you very much. Getting back into this, I will have an email address at the end. USA only. I'm not going to ship these outside the U.S. Right now. We'll worry about that another time. But for one of these cups here, email me. Make sure that I have your information when you do. And tell me what your favorite coffee is. Maybe we'll, the winner will be the one that we use on the show. And be sure, because I'm going to mention your name. Chances are I won't get any, but we'll see what happens. It is a free coffee cup after all. You do not have to be in the industry to win. And that's it. Have a great day. Don't forget, like and subscribe.